Before watching this video, you should have watched the Introduction to Basic Probability Rules. The last part of that video was a summary of a rule called the addition rule for mutually exclusive events. And that's a rule I'd like to explore a little bit more with some examples. So we learned that mutually exclusive events mean their outcomes have nothing in common. So either a day student or a boarding student is one example. Here are some other examples. Say we're at a stoplight and the color can be red, yellow, or green. Because we could never see more than one color at the same time, we call the events seeing red, yellow, or green mutually exclusive. We can never see both colors at the same time. Next example. We talked about this one, or similar. We select a student at random from the Wilson student body and we record whether the student is a day student or an international student. And I've talked about this example a number of times in class, and sometimes people say, no, there are no students who are both day and international. But a couple of times I've heard students say that there are one or two students who are classified as international students but are also day students at the same time. So if there are students who are both, then we can't say that those events are mutually exclusive. Here's one more. Select a student at random from the Wilson population, record whether this student is taking calculus or probability and statistics. Now, I'd encourage you to think about what would make these events mutually exclusive. And I hope you'd come around to realize that if there are students who are taking both calculus and probability and statistics at the same time, then we can't call those events, these are the events, we can't call them mutually exclusive. At this point, it would be good for you to see if you can think of events that are mutually exclusive and events that are not mutually exclusive. You might think of rolling a die once and recording whether the result is even or odd. So rolling a die and recording whether the result is even or odd, the events are whether it's even or odd. We would say that they are mutually exclusive because we can't roll a 2 and a 3 at the same time. For example, we can't roll even and odd at the same time. We could also think of maybe rolling a 5 or a 6 as the outcomes we're interested in. Again, we can't roll a 5 and a 6 at the same time, so rolling a 5 and rolling a 6 are mutually exclusive events. Next, let's think of some events that are not mutually exclusive. So they have something in common, they have an overlap. In other words, it's possible to find outcomes that meet both characteristics. We've seen a couple of these, and one classic one is drawing a card that is a face card from a deck and heart. So we're drawing a single card from the deck and recording whether it is a face card and a heart. It would be very good for you to stop and think about why drawing a face card and drawing a heart are not mutually exclusive events. And here's the reason. If we take a look at our cards and our deck of cards, we would see that there are 3 cards that are both face cards and hearts at the same time. So the Queen of Hearts, right, we'll call it, let's start with Jack. The Jack of Hearts is both a face card and a heart. The Queen of Hearts is a face card and a heart, and the King of Hearts is a face card and a heart. So these two events are not mutually exclusive because there are cards that meet both characteristics. If you think you get it and you're ready to do your homework, you can stop here. But if you'd like a few more examples, you can take a look at the next part of the video, which is applying probability rules. Okay, so this looks a lot like what you'll see on your homework. So we're looking at a traffic light, and we're observing that when we arrive at the light is green about 35% of the time. So we would represent this with P parentheses green equals 0.35. And then we ask in this question, what is the probability that the light isn't green when you get to this intersection? So isn't green is giving away that we need to use one of our new basic probability rules, and that's the complement rule. So we would say probability of not green, and I'm going to go ahead and use some really formal notation here, is 1 minus the probability that the light is green. So we're going to go ahead and just say 1 minus 0.35 equals 0.65. So that's the probability that the light is not green. So it's either yellow or red at that time. Now let's try using the addition rule for mutually exclusive events. When you get to the light, we know that it's green about 35% of the time, and suppose we also find that the light is yellow about 4% of the time. We want to figure out what is the probability that the light is red. So notice that red is the only other possibility, and we know that the probability of all outcomes, right? So we could say probability of green or yellow or red has to equal 1 because there are no other possibilities. So if I want to know the probability that the light is red, then I'm going to have to subtract from 1. So I'm going to use both of my rules. I'm going to find the 1 minus the probability that the light is green or yellow. Okay? So then let's fill in the things we know. I'm going to still have my 1 minus, and then I'm going to put larger parentheses around this, and I'm going to write out every single step. I need to find the probability that the light is green or yellow. I'm using my addition rule for mutually exclusive events. So I'm going to be adding those probabilities and then subtracting from 1. So the probability of green was 0.35. The probability of yellow was 0.04. So I end up with 1 minus 0.39, and that gives me 0.61. And that's my answer. That's the probability that the light is red. It's the only other possibility after we take away the probability of green or yellow. Okay, so at this point you should be able to use the basic rules of probability, and you should be able to combine them as well, and that's what this problem did. It combined actually 3 different rules, I would say. The probability of all sample space of the sample space is 1, the complement rule, and the addition rule for mutually exclusive events. So now you should be very ready to do